Okay, so now we're going to finally produce our own confidence interval from scratch. And there's two methods. Of course, there's a formula and there's a calculator way. We're going to do the formula first so we understand what the calculator is doing. Once you get the calculator down, you don't have to continue to use the formula, but I'm going to go through it once. So method 1 says find p hat and e and use this scary looking formula. But I claim that we know everything in that formula. Or we can find it if we don't. So it says, let's not example 2 anymore. I am in the middle of page 87 where you see that formula for E. It says Z alpha over 2 times the square root of P hat times Q hat over N. Weird looking formula to find the margin of error. But the Z alpha over 2 is what we were just practicing. So we have to be able to look up a critical value. That's just one number right there. P hat's going to be your sample proportion, which once we have a problem we can get that. What do you think Q is? The complement of P hat, right? And N is, not population, sample size. How many number of people or things? So we're going to use that and do example 5. So example 5. Let's talk about what they gave us here. We're back with Mendel and his P's. He won't go away this semester. He keeps coming back and messing with those P's. So he's doing his famous, now famous because we do it every day it seems, genetic experiment with his P's. He had one sample of offspring that had 428 green and 152 yellow. I'm going to write this down just to be organized so I put my paper down. 428 green, 152 yellow. We want to find a 95% confidence interval. By the way, I will start abbreviating the word confidence interval as CI, just because it's too long to write out. But we want to find a 95% confidence interval for the percentage of green peas. They're asking us to come up with our own interval, like the one we started with today. The question is, how the heck do we get there? We have to have a p hat and we have to have an e, because remember, it's always p hat plus or minus the e. P hat we talked about an hour ago. P hat is the sample proportion. In this problem, we're talking about the proportion of green peas. Green? What proportion of my sample was green? 428 is the number that were green. How do I make that a proportion or a probability?
You put it over the total?
Yes. P hat's just how many greens you had out of the total. And we had 428 greens out of 580. I was adding those, thank you. 7.3. Give me a couple more digits.
0.7379.
79?
0.738.
If we round it, it'll be 9 right there?
No, you're good.
7379? Okay. So almost 74% of his peas were green. That's the proportion from his sample that were green. So now that he had a sample that's green, he's like, well, what is it from my whole population? I don't want to count all my peas because I've been doing this forever now. What can I do to estimate what it is for all my peas? So this is his p hat, the sample proportion. How many, what percent were green? So to find my margin of error, I need a few more things. We need the critical value. We'll get to that in a minute. P hat we just found. What's Q hat?
You just
1
subtract
minus
that
p
from
hat.
Yeah, we subtract it from 1. It's the complement, just like it's been all along. So we can find Q hat.
0.2621.
1 minus P hat. 1 minus 0.7379 is 0.2621.
Yep.
So I have P hat, I have Q hat. Do I have N? What's N? 580, your total sample size. We were looking at 580 Ps. So we have N. I have everything except for my critical value now. I have P hat, Q hat, N. I need my critical value, which is why I put the little picture there for you. So let's use the picture of the normal distribution to find my critical value. So we are now looking for a 95% confidence interval. So what area is inside my interval? Inside 95, right? If it's a 95, I need 0.95 in here. So how do I find, yes ma'am?
How'd you know it was 0.95?
Because it asked me to find a 95% confidence interval.
Oh.
So that tells me what percent they want in between the two numbers. I now need to find alpha, the area on the outside. How do I get alpha? Yeah, 1 minus 0.95? 0.05, right? If I have 95 on the inside, I have 5% on the outside. And then I want to divide it by 2 because the 5% is both of these combined. So this guy right here is 5% divided by 2, which is 0.025. That's what's in this tail and in this tail. Again, this is the area outside. This is the area in one tail. Why am I drawing this picture? What am I trying to find? Say that again?
The interval?
I'm trying to get the interval, but what piece of this problem am I looking for at the moment? You're right. But there's a certain thing I'm looking for at the moment. We're trying to do P hat plus or minus E. We got P hat.
Where's find E though?
We're trying to find E, and E needs P hat, Q hat, N, and this critical value right here. That's what I'm doing with the picture, is finding that critical value. I want to make sure everyone knows what we're doing. So I'm looking for the Z of alpha over 2. That's what I need in my formula there. In this problem, what's alpha over 2? 0.025. I'm looking for the Z right here. If we were talking about the Z axis here, I'm looking for what is this Z right here that gives me 0.025 to the right. Everyone okay what I'm looking for? How to find it's another question. I have 2 ways to find it. If I'm looking for this cutoff Z right here, question mark, this guy right there, there's an area of 0.025 to the right.
Inverse norm?
Inverse norm. Anytime you're looking for that cutoff, the Z, we would do inverse norm. Or, what's the other option? Use the table and work backwards from the table. Here's the tricky part though. What number goes into inverse norm here?
0.975.
I heard lots of voices. It's not 0.025 because I always have to tell my calculator the area to the left. 0.975 she's saying. 1 minus this essentially.
Or you could just take 95.
Or you could add these, 95 plus, oh yeah, you could add those two, or you could take the complement. But do we all agree that 975 is the area to the left? Everything to the left of my hand here? So you can either search your table for 0.975, Or you can do inverse norm of 0.975 with what mean standard deviation? 0 and 1. Every time you're looking for z's, it's 0 and 1. And we get
1.96.
1.96. Yeah, table gives you 1.96. All right. What is that?
See?
That's my z. My z alpha over 2. My z that has O25 to the right. It's a lot of stuff. But technically, there's only two things, I'll argue. P hat, we had to calculate. Okay, we had to calculate Q hat, but it was a little subtraction. We can handle that. That was a complement. We've done enough complements, right? And then we had to know how to look up critical values. Now I'm ready to find my E, finally. I'm ready to find E. So E equals, my Z comes first, which in this problem was 1.96, times the square root of, here, that was my 1.96, right? Times the square root of P hat, which was 0.7379, times Q hat, hang on, I gotta multiply it by Q hat, 2621, all divided by my N, which was 580. Yes, sir.
Will that turn into 1.96 times 0.0182?
It might, I can't do that in my head. So now the challenge is to see who can type this into your calculator correctly and see if we all get the same number. You can type it in pretty much the way you see it into your calculator. Let's see if we can all calculate the same margin of error. We'll see if we agree with Hector. You guys have questions on where these numbers came from?
Where did you say you were?
I'm just kind of confused on the 0.975, where did you get that in the inverse norm?
Because we're looking at the area to the left of this. Use green.
I thought it would be 0.95.
Everything to the left. 9.5 only gets me to here, but there's another piece over here. If you look at this red piece,
That's only, okay.
0.95 only takes you so far, we have to go all the way to the end.
Okay.
So it's 95 plus another 025.
And then, just get that number off the inverse norm, we can just look it up on our table, right?
Yeah, you can look it up in the table or inverse norm.
Okay.
Or table. Are you checking with each other to see if we all got the same E? 0014 in
What'd
here?
you get?
0.0358.
0358?
I got it.
Where's the decimal?
0.0358.
0.358.
Okay, so let me tell you something. If you did not get 0.0358, unfortunately, it's operator error. Yes, sir.
I got 0.00358.
2 zeros or 1 zero?
Well, I don't know.
So if you got 2 zeros, you probably either added a zero or lost a decimal somewhere when you typed things in. So that's my point. If you didn't get this right now, in the interest of time, just put a little star there and tell yourself to go back and try it again, because it's you typed one number in wrong, you added a decimal, or you lost a zero. It's easy to make a mistake typing that in. The good news is, let's say this is on an exam. This problem's on an exam and you've written this out. If you have this written correctly, but this number over here is wrong because you typed it into your calculator wrong, you're going to get almost full credit for this problem because you're telling me you know what to do. You're just telling me that you messed up when you typed into your calculator. So then when you keep going with those numbers, I'll be able to make sense of it. So if you didn't get it right, just put a little note when you have time to go back and try to catch that. Okay, big picture. We're still working on example 5, which asks me to find the 95% confidence interval for the percentage of green peas. That was like 20 minutes ago. Remember confidence intervals we started talking about are P hat plus or minus E.
So we're gonna minus 0.7379 15.0358.
Yes, we're going to take our 7379, which is our p hat, and we're going to add and subtract our 0358, that's our e. So at this point, to get my confidence interval, I'm going to take p hat plus or minus e, which in this case was 7379, and I'm going to add and subtract 0358. I found the p hat and I found the e. I have to point out, it's pretty amazing, considering all we had was this information right here. We have two numbers. We had all this and all this information. This is going to make your calculator be your best friend in about 5 minutes. Everyone okay? We're adding and subtracting that e to the p hat? What do we get
0.7737.
on the top or the bottom?
Top,
7737.
0.7021.
Say it again.
0.7021.
7021. We agree with Brian? What is this? It's a confidence interval for the proportion. Oh, read the question again though. It wanted a percentage.
So you just move the decimal over to.
We just need to move the decimal over, but make sure you read the question again, because this will happen online, where you're doing this problem, you get all the way to here, and you're right. But you didn't read that they wanted percentages. This is a proportion, but since it asked for percentages, we're just gonna move it over. And the answer will be 70.21% to 77.37%. This is the one for the percentage. Yes.
So do you have to write it that way where you do like the less than p and less than that, or can you just do like the percentage comma and then the next percentage?
If you don't put the P between there, it gets a little confusing, because as we go through chapter 7, we're gonna find confidence intervals for proportions, for means, for standard deviations. And so if you don't label it, I don't know if you think it's a mean or a standard deviation or a proportion. So we do wanna put the P in between that. Right now, they're all P's, so it seems obvious, but it will get mixed up in a minute. So that was method 1. I want to read the question at the bottom before we talk about method 2. Mendel expected that 75% of his peas would be green. His sample was not 75%. This was his sample over here. His sample was 73.79%. So he thought the population would be 75%, but his sample wasn't. Do his results contradict his theory?
No,
Why not?
it's within the
Because they're
line.
within.
Ah, because 75% is within here. We didn't get, you can't expect, go back to my coin flipping problem I always talk about. If I flip a coin 100 times, you expect me to get 50 tails, but there's no guarantee I'll get 50. I might get 51 or 52. There's some range that's acceptable, right? So he didn't get exactly 75%, but that means his population percentage is somewhere between 70.2 and 77.37, and 75 is in there somewhere. So it does not contradict his theory. If his theory was that it was 80%, then we'd have a problem, because 80 is outside of our interval. You stretching? Any question? Or both?
So E can kind of be seen like the standard deviation in these kind of things. When you draw it out, you can consider it like that, how far away it is from the mean.
Yes,
and the middle.
it's not just the standard deviation, because you know how we count by standard deviations and we say 2 standard deviations away? You know that 1.96 that we had right here? That's close to 2. This is telling you 2 standard deviations. So E is how many standard deviations away, not the exact standard deviation. But it's similar in how far away from the middle can you go. So it's like our 2 standard deviations away. It's roughly 2,
Right,
it's almost
round
2
up.
times that, Okay, so here's where your calculator becomes your best friend. We could have done this whole problem in about 12 seconds. 12 seconds. I wanted to make sure, though, that you understand what your calculator's doing before we did it. So it says up above there, method 2, right in the middle of the page. We have to go somewhere we haven't been before. You go under stat, our old stat button, and then you move over to tests. And look for 1 prop z int. See if you can find that. If not, I'll pull it up on my screen, but I have a feeling that you can help each other get to there. Stat and tests, and then you go down to 1 prop z int. Over to tests, till you find 1 prop z int. I want to make sure you all find that button first. I don't remember off the top of my head what the old calculator asked for. Does it just give you parentheses? Kevin, you have one of the old ones. Did you find 1 prop z int?
Yeah.
Does it just start with 1 prop z int in parentheses? Or does it ask you for certain things?
Ask for X.
Okay.
X and Z.
Okay, good. I couldn't remember. So it should ask you for X, N, and C level.
Mhm.
Mhm.
Before we fill those in, is there anyone who's not at this point yet? We're all looking at that? Okay, let's talk about the ones we know. N has always been sample size. In this problem, what was sample size?
580.
580. The C level is your confidence level written as a decimal. Has to be a decimal. So what was our confidence level in this problem?
0.95.
0.95. And X is the number of guesses to whatever the question was. In this case, the question was how many greens, because we were looking for percentage of greens.
So
How many greens did we have?
420.
428. These are whole numbers. They're not percentages. These are whole numbers. We're counting. How many in your sample, how many were green? Calculate. Move down and hit calculate. That's what's next, right? What's it give you?
Same answer that the square.
It should give you this answer. It doesn't know the question asked for percentages. It should give you this one with probably some more digits.
Yeah.
Mhm.
Awesome, I know.
Yeah.
There's a love your calculator in this class.
Make it worth
Make it worth $100 and whatever dollars it costs, right? So it took you straight to here, and now all you have to do is recognize that the problem said what was the percent, so you'd only have to go to here.
So
Wow.
you wouldn't even have to do like the inverse norm or anything?
You don't have to do any of this.
As long as we have the information given, like we did in this one.
Correct. Now, but let's say this problem said, what's the margin of error? We didn't,
It's-
and you could do this to get the margin of error, if you wanted to, but what did we do to find margin of error before the break today? Yeah, we just found the middle, the p-hat, and we subtracted to find e. So you could still use those techniques to find margin of error. If you ask the online program for help, it'll tell you to use this formula every time. It doesn't know that you have an amazing calculator. So you have to still know that p-hat's in the middle, margin of error is the difference, so you may have to do some subtraction if the problem asks for that.
How do you know what number to take off your calculator? I mean,
It should just be the parentheses, there should be 2 numbers separated by a comma.
Yeah,
So you want both those numbers, because those are the edges of your interval.
70214, okay.
You see it now?
Okay.
So it's giving you both those numbers separated by a comma, yes.
Okay.
So if they wanted the margin of error, would we just subtract the 7737 from and the 7021 to find the margin of error? Or?
We'd subtract the p-hat, remember the p-hat's in the middle? Where's the p-hat? So in terms of a picture, let me kind of draw it over again.
Oh, yeah, we would subtract, okay, I got it.
You already answered it?
Yeah, I just,
7379's in the middle, and you've got this number over here. This difference over here would have been your margin of error.
Yeah.
So you don't even ever have to use that formula again. As long as you know what your calculator is giving you, which is why I insist that you put the P in there, that you know you're finding a confidence interval for a P. Okay, let's try another one. I think we can do example 6 in about 2 minutes, as opposed to 20. Example 6. 230 out of 600 teenagers plan to see the new Hunger Games movie. Find a 90% confidence interval estimate for the percentage of all teenagers planning to see the movie. This must be old, so I don't think there's any more Hunger Games movies to be made, but that's okay. Maybe there's a new one that we don't know about. So as soon as I see that it wants a 90% confidence interval for the percentage, that tells me I want to do what? I want a 90% confidence interval for percentage. Where am I going to go as soon as I read those directions? One prop Z int is our new best friend. One prop Z int is because I'm dealing with one proportion. I'm looking for an interval. The Z is because we're working with Z's as our critical values. That's what all that has to do with. So it's kind of the shorthand for everything we're doing. And what am I going to tell it? 230 was our X, 600 was our total, and 0.90 is our sea level. The hardest part of this problem is reading and understanding that you want a 90% confidence interval for a percentage, and knowing that you have to go to one prop Z int. Your calculator gives you some numbers that we are going to write like this. P is between, I didn't put it in my calculator, I'm trusting you. 0.3507 and
1460.
can't be
Oh,
right.
sorry, 4160.
Okay. Oh my God, smaller. Did we get the same numbers, Ms. Carey? Am I done? Ah, it asked for a percentage. If it asked for the proportion, I would have been done. If it said what proportion, I would have been done. But since it asked for percentage, we'll just turn those into percents. Oops, lost my percent sign. It's before. So your calculator doesn't know that you were asked for percentage. You have to know that part. Okay? The follow-up question says that the movie theater claims that 25% of the teenagers are going to see the movie. Does their claim appear to be correct?
No.
No, why not? 25 is not in there. This tells me that there's more people coming than the movie theater thinks. So maybe they need to open another screen, they need to hire more people to work that day. Yes, Samantha?
What's like the best way to write that?
To write what?
Like the explanation.
No, 25% is not in our interval. That's exactly what I would write.
It's not in interval.
Not in our interval, yeah. Because our interval says we're pretty sure it's between here and here. It's outside. I mean, we're 95% sure that it's in there, so